Homework Hotline, what is your emergency?
Hello, I'm Becca. I teach math at Emily Griffith High School, and I'm really glad that you're here for our new season of Homework Hotline.
Hi, I'm Nathan. I also teach math at Emily Griffith High School, and I'm also glad to be here for this new season of Homework Hotline.
So we'll help you out if you get stuck. Do you need math help? Well, that's why we're here. We'll help you to work through the problem so that you can better understand how to get to the answer.
We're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. We'd love to talk to you and help you out with your homework, so give us a call at 720-424-1666. Giving us a call allows us to help you more individually with your specific problems.
You can watch our show in several different ways. You can tune in to Comcast, Channel 22. You can go to livestream.com and search for EG Homework Hotline, or you can watch us on YouTube by searching for DPS TV Homework Hotline.
The Homework Hotline is sponsored by Emily Griffith High School.
We also have an Emily Griffith High School student with us today. So, Lily, why don't you introduce yourself to everyone?
Hi guys, I'm Lily, and today I will be your trivia queen and social media master. Now, every day I will ask you, the audience, a trivia question, and before the end of the show, I want to hear it from you guys. And the subject, it can be on any subject. And as your social media master, I will be grabbing your questions from the social media board and giving them to the teachers to answer them for you. And so today will be an English question on your trivia. And today's trivia question is, which word is most mispronounced in English? Which word is the most mispronounced word in English? And I will see you about that at the end of the show.
Thank you, Lily. Great question. I don't even know. I'm not sure what it would be.
I don't know. I probably mispronounced so many words.
I know.
I wouldn't have a first guess.
Without even knowing. I'm not
Right.
even sure. Well, if you have an answer to the trivia question, give us a call. The number is 720-424-1666. I'd like to give you also the other ways that you can get in contact with us, because calling is one way, but you can also get in contact with us a few other ways. One way is through social media. You can find us on Facebook or Twitter at EG Homework. You can text us at 970-680-3771. Or you can even email us at homework@emilygriffith.edu. So those are all the different ways that you can get a hold of us. Calling is definitely the best way because we can help you instantly and right away and make sure that you can understand the problem for sure. But you can definitely get a hold of us those other ways too. So answer to the trivia question and your questions, and we'll be here till 5:30, so give us a call. So let's actually go check in with Lily and see if we have any questions awaiting for us on social media.
All right, guys, so today's first question is, find the length and width of a rectangle whose perimeter is equal to 160 centimeters and its length is equal to triple its width.
All right, so that sounds like a geometry question, so I guess I can take that.
We'll leave it to you.
Yeah, that sounds good. So these problems always sound a little bit complicated. There's just a lot going on. So the question again was to find the length and the width of a rectangle whose perimeter is equal to 160 centimeters and its length is equal to triple its width. So again, that's a lot to say. So what I like to do is just kind of break that down into a couple different pieces. Just read a small section at a time and think about what is really happening. So if we go to my board here, the first thing we want to look at is we want to find the length of a width of a rectangle. The perimeter is equal to 160 centimeters. So just think about perimeter and kind of what that means. And so I'm going to write down really quick the length and the width of a rectangle. Its perimeter is 160. So length and width equals 160. Well, if I look at a rectangle, it's got two lengths and two widths. So again, just taking a look at what it looks like. I'm going to do it like this. So I got a length here, I got a length here, a width here, and a width here. So if you just remember that the perimeter is actually all the lengths and all the widths added up. what we have is two lengths because a rectangle has two lengths. And we have two widths because a rectangle also has two widths. And the next part said the length was equal to 3 times its width. So again, just writing down everything that we know from that original problem, we see that what we really have here is two equations. So when we take a look at this, what we have, the issue with solving this is we have two variables. So we need to get that down to one variable. And if we take a look at this problem, right here, we know that the length is 3 times its width. So we can actually take this and plug it back into, substitute, into that perimeter equation we originally talked about. And what you'll see by doing that is we get this down to one variable, which becomes a bit more manageable to solve. So I'm going to substitute anywhere there's an L here for length with 3W. So all I'm doing is substituting and then kind of rewriting this entire equation. Now, when you see this equation, it becomes something more manageable that you're more familiar with, which is just, an equation with one variable in it. So I just simplify this, 6W plus 2W equals 160. And then I go through my steps of combining like terms and simplifying this equation. So 8W equals 160. We divide by 8, and we get a width of, 20. And that was in centimeters?
Yes.
So the problem was actually asking for the length and the width. So far we figured out what the length is. So now we need to use that to figure out the width. We can go back up here and solve using either one of these equations. But I personally am going to pick the one that looks a little simpler. So this one right here is probably going to work best. So length equals 3 times the width that we just solved for, and your length is 60 centimeters. And again, you can double check this by just plugging it back into both equations and making sure it works. But again, these problems, they seem really complicated when you first look at them, but if you just take a second and try to read through it slowly, you can break it down into 2 more manageable problems.
All right, great. We did just answer one of our questions through social media. If you're just joining us now, we are answering homework questions. Our phone number is on, you can see it on the top of your screen. It says 720-424-1666. You have until a little bit before 5:30 to call and get your questions answered.
And we hope to hear from you.
Absolutely. So in the meantime, let's go back to Lily and get some more questions answered.
Okay, so the second part of their question, well, I shouldn't say part, but their second question was, the sum of two numbers of 2 is 64. The difference of the two numbers is 18. What are those numbers?
So the sum of two numbers of 2 is 64. I'm not sure.
I think that might be a
You
typo.
think it's a typo?
Unless it means multiples of 2, but I think it's a typo.
Okay. We're going to assume that part of 2 is a typo. If it is not, call us or write us another question so that we can fix it. But I'm going to assume it's a typo. I'm going to go with that, and I'm going to use the information then that we have. So, okay, so we have, I'm writing that information down right now. So what we were told is that the sum of these two numbers is 64. The difference is 18. So first, before I actually go into writing any equations or anything like that, I want to break down these two words real quick. Sum, the definition of that is basically the answer to the problem when we add. So when we add the two numbers, it's the answer. And then difference, what that means is the answer when we subtract. So that's definitely important information for solving this problem, is knowing what sum and difference mean. So from here, I'm actually going to write two equations with two variables, kind of like we did yesterday. So if you tuned in yesterday, you saw us solve equations with two variables. If you have two variables or two unknowns, then you need to have two equations. So I'm going to call the two numbers that I don't know, we're going to call them x and y. Those are going to be our two unknown numbers. And we know that when you take x plus y our answer is going to be 64, or the sum is going to be 64. If we take x minus y, so when we subtract them, our answer is going to be 18. So again, what the difference means. Now, yesterday I said that there were two ways that we can solve systems of equations. One is with substitution, which actually you just saw Nate do with the first question, substitution. And then the other way to solve them is with elimination. And that's the way I'm going to go with again today, just like I did yesterday. Elimination is when you have variables that are opposite of each other. And what we do is we combine our equations with those opposite variables so that they eliminate each other. Opposites always equals 0 when we combine them together. So we're going to just take both of our equations and combine them. So right now I have x, or also known as 1x, and 1x, and when I put them together, I have 2x. And then here I have positive y and negative y. Those are the opposites that are eliminating. Positive 1y and negative 1y together give you 0. So they're gone. Then on the right-hand side, I have 64 plus 18. That's going to give me 82. And then at this point, what's great is now I just have one equation and one variable. And it's also a relatively simple equation to solve. So 2x equals 82. All I need to do is get the variable by itself by dividing both sides by 2. And I end up getting x is 41. So one of my numbers is going to be 41. I need to find the other number now. I know that, back to this first equation, I know the sum of my two numbers is supposed to be 64. So 41 plus my other number is going to give me 64. To find that other number, I'll work backwards and undo to get my unknown by itself and subtract 41 from both sides. That means I'm left with 23, and that is my other number. So the two numbers that I was finding were 41 and 23. And you can even double check them too to make sure that the answer when you subtract is 18, and then the answer when you add is 64. So there you have it. It's another systems of equations. Two unknowns, two equations. So hopefully that helps. All right, so we're going to, one of the things that we do on Homework Hotline, I should explain, is we like to make some pre-recorded segments on topics that are a little bit more basic, but are also commonly misunderstood. So I did a back to basics on central tendency, and you'll find out what that is in just a second. Welcome to Back to Basics. Today we're going to learn about measures of central tendency. Central tendency kind of sounds complicated, but all that is finding the mean, median, mode, range, and maybe some outliers when it comes to a set of data. This is a middle school concept that sometimes is really confusing, and the reason why is because these words starting all with the same letter makes it kind of difficult to remember which is which. The mean is always going to be the average value of all of your data, and I'll show you how to calculate all of these as well in a minute. The median is the middle, and I remember this one because I think of when I'm driving in the road and I think of the median in the road is always in the middle of the road, and so that's how I remember that the median is the middle number of our set of data. The mode, and I kind of go with the way that this sound, mode is the number that occurs the most. So the mode occurs the most. It's the number that happens the most in our list. The range is, I kind of always think of, well, how wide do our numbers range, or what is the range of this? It's the difference between the largest and the smallest values in our list. And then any outliers are numbers that are going to be outside of our data or outside the main basically a number that is furthest from your data, or something that's way different than anything else, an outlier, or like an outsider. Think of an outsider. So it's something that is way different than the rest. I'm going to show you an example of how to calculate all of these things using this set of data. If you're doing the mean, like I said, it's the average. You are adding all of these numbers up, and then you divide by how many numbers there are. So when you add all of these numbers up, you're going to get 85. So just 12 plus 11 plus 14 plus 8 and so on. You get 85. And then that 85, we want to divide it by how many numbers there are. So there are 8 numbers in this data set. And our average, when you actually end up dividing this, you get this number here. And this is our average, or our mean. And you'll sometimes hear it being called average or mean. So that's the 10.625. Now, the median, or the middle number, this is where we have to put our numbers in order, or our data in order, from least to greatest. And I always get in the habit of even doing this first, just because you need the numbers in order for median, and you pretty much need them in order for mode. And then it also helps you calculate range and any outliers too. It helps you see it a lot easier. So I'm going to go ahead and put this data in order, and you'll notice that I'm going to be marking off the numbers as I write them. And the reason I'm doing that is so that I know which numbers I've already written and which ones I haven't gotten to yet. And that also helps me make sure that I haven't missed anything. And as you can see, look, I missed the 8. This really helps with that. It helps with making sure that you don't miss anything. And I have lastly 14 and 14. The other thing, and this is a big trick, this big hint, is count your numbers after you've done it to make sure that you have the same amount of numbers in your original list that you do in your list whenever you put it in order. The biggest mistakes I see whenever people are putting their numbers in order is they forget a number, and then that messes up the whole thing. So once your numbers are in order, then we can go and we can start finding which one is the middle number. So I'm going to just kind of mark off ones as I count, just so that I can work my way to the middle. Now, this set of data is kind of special, because if I were to go the whole way to the middle, I'm not really actually at a number. So what that means is that there are 2 numbers in the middle. And with the 2 numbers in the middle, what we have to do is find the average of those. And when we find the average, that's going to be our median. So the number halfway in between the 11 and 12. What that'll work out is going to be 11.5. So that's our middle, or our median. Mode is something that occurs the most. Something that people don't know all the time is that you can have more than one mode. You also might not have a mode. If we had a list of all different numbers, there wouldn't be a mode, because there wouldn't be some number that occurs the most. In this case, you can see that I have 11, that happens twice. I have 12, that happens twice. And I have 14, that happens twice. So actually, in this case, I've got 3 modes, 11, 12, and 14, because these numbers are occurring in my list the most often. Range is going to be the difference between the greatest and the least value. So if your list is in order, easy. All you have to do is take your last number and then subtract the first number, or the smallest number, and that's your range. So our range is 11. Any outliers are going to be numbers that are far away from your data set. What you can do is you can look at your mean, median, mode, and you can see that these are all very close to, they're higher numbers, around the number 10. So if you have a number that is very far away from that, then that's going to be an outlier. In this case, I'd say that the number 3 is an outlier, because it's far away from the rest. But all of these processes you can do with just one list of numbers, and they're basically measuring where most of our data is. And it gives us kind of a number to generalize what our data says. So hopefully this helped you find and figure out how to find central tendency, and also maybe some tricks to help you tell the difference between these 3 mean, median, modes, these big M's. Welcome back. Those back to basics are they're made they're made in order to help you out with topics that might be maybe a more basic topic, but just might be a little bit confusing sometimes. So hopefully you learned something.
Yeah, and it's always just helpful to review those kind of basic terminology, basic skill sets for math.
Really is. Absolutely.
So
Go
just
ahead,
a
give us our-
reminder, we're taking calls to answer your homework questions. You can give us a call. It's in the top of your screen there at 720-424-1666.
And we actually have our first caller of the day, so
Oh.
we'll go ahead and take that. But still, that number's there, so you can call in. All right, so are you there? Hello?
Hi.
Hi, thanks for calling Homework Hotline.
Hi. I'm a senior in high school, and I'm having a little bit of an issue with the story problem.
Okay, let's see if we can help you.
If Tony makes 59.6% of his free throws, how many free throws would he make if he took 31 shots?
Okay, I can take that one. So let me just make sure I got that. We're saying that Tony makes 59.6% of his free throws, and he's taken 31 shots. We want to get an idea of how many he's going to make.
Yep.
All right. So this is like kind of an expected probability question. So what we're doing is we're saying, okay, he makes 59.6%. What do we think he's going to make in 31? So this is kind of a mathematical expected probability, meaning he's not going to make exactly as many as we kind of mathematically calculate here, but this is a good kind of estimation. So first of all, when we look at percentages, what are percentages always out of?
Percentages are always out of 100.
Yeah, so if we take a look at this, it's almost kind of like a proportional problem. So 59.6, and actually, yeah, so this is going to be out of 100. When we talk about percentages, 59.6 out of 100 is approximately what he's going to make on average. And we're saying he's going to take 31 shots, and we want to know how many he's going to make. So when we talk about, again, these percentages, we're saying if he took exactly 100 shots, we're saying mathematically he would make exactly 59.6. But now you're saying in this problem, what if he took 31 shots? Well, we want to figure out of 31, how many will he make? So one way to set this up is 59.6 out of 100 should have the same proportion as something out of 31, and that's what we're really trying to figure out. Does that make sense?
Yep.
Okay, so when we have these kind of fractional proportion problems, we can always just cross multiply here, and we end up with 100x. So we just cross multiply 100 times x.
Okay.
And that's going to equal 59.6 times 31. That's what we're looking to solve for. So fortunately, I can't do all of this in my head. So if I pull this up in my calculator, 59.6 times 31. So we're going to end up with 100x, I'm not doing anything to this yet, equals 1,847.6. And the last thing we need to do, since we're solving for x, we're trying to, where x represents the number of shots he makes, we're just going to divide by 100 to get rid of that on both sides. These cancel out. X equals 18.48. So again, this is kind of an expected probability. We don't know that he's going to make exactly 18.48 shots, and it's not actually possible to make almost half of a shot. So this is a good approximation if we were trying to guess how many he would make out of 31. That's what we would do. Also, if we're doing percentages, we could also just take our 31, a quicker way to do this, multiply it by 59.6, that percentage, and then divide by 100. It's kind of a quicker way to do this, and you'll get the same thing.
Awesome. Thank you.
You're welcome. Thanks for calling.
Awesome. A good point to be made is that proportions, they've got a lot of different ways that they can solve them. And I like that you pointed out, all right, here's one way, cross multiplying, and then the other way is doing the straight up, just the direct percent.
Right.
And there are a bunch of other ways too, equivalent fractions maybe as well, but proportions can be solved a lot of different ways. So kind of just an interesting point to make, I guess. I don't know. All right, so let's go back to social media and get another question from Lily.
All right, so we have a question from Jay, which nice icon, Superman icon there. Batman is better, but that's feasible to the point. Factor 3x minus 12 is the question.
All right, I think I can take that one. Go ahead to my screen and that way we have some visuals about what I'm talking about. But this word factor confuses a lot of people. So I'm going to define this first. A factor, well, let me give you an example. Let's say I had 2 times 3 is 6. The factors are 2 and 3. So if I were to say factor the number 6, we could say 2 times 3 is 6 when it's factored. So what you're really doing when you factor something is you're dividing, or you're breaking it down into the things that multiply together to equal that. So factoring something like this, an expression, 3x minus 12, factoring something like that means what we have to do is break it down into the things that multiply to equal that expression. And so if we want to be able to break it down or divide, what we need to find is a greatest common factor, meaning what can go into both of our terms. So we have this term 3x, and we have a term negative 12. And what we're doing is we're asking ourselves, what in these numbers, the 3 and the 12, what can we take out, or what can they both be divided by? And 3 goes, the numbers that go into 3 are 1 and 3. The numbers that go into 12 are 1, 2, 3, 4, 6, and 12. And 3 is the common number that can go into both of them. So what that means, what we can do is take out 3 from both of our terms. And again, when I say take out, I mean divide. So when I take the 3x and divide it by 3, I'm left with just x. And when I take the negative 12 and divide it by 3, I'm left with negative 4. And so when we are factoring, it's almost like, I've heard kids call it this before, reverse distribution or backwards distribution. If you were to distribute or multiply this back together, we should get the same thing we started with. So 3 times x is 3x. 3 times negative 4 is negative 12. So it does multiply back together to get it, but this is our factored form, the 3 times the quantity of x minus 4. So basically, we broke it down into its 2 factors. One of them is 3, one of them is x minus 4, because 3 times x minus 4 gives us that expression we started with. So hopefully that helps. Basically, you're finding what goes into both of our terms.
Yeah, I really like that. I think just understanding what factors are makes it a little bit more clear about what you're doing when you're factoring, aside from just like, these are the steps, but really kind of getting...
Right, you're just looking for this and writing this down and whatever. If you know what factoring means, whenever we think of whole numbers, it's a lot easier whenever you're doing it in algebra as well.
Definitely.
So.
Well, it sounds like we have a little bit more time, so we're going to cut back over to Lily for another social media question.
Okay, so apparently they've been having to try and figure this out for an hour, and so they don't know how to go about doing it, and so they want to graph y is greater than negative 1, the maximum number of spaces in x and y only go up to 10 or negative 10.
Okay.
That is a very weirdly worded question.
Okay, so I think that means when they say the maximum number of spaces, I think that might mean
Maybe looking at the graph.
the range.
Yeah.
Yeah, of the graph, or the scale of the graph is going from negative 10 to positive 10. Okay, let's see if I can't get a some grid paper on here, some grid lines, and it says graph y is greater than negative 1. Okay, we'll do it. So I hope I'm answering your question fully, but we'll do what I can. So if you go to my screen, it seems to me, so if this is not what you're asking, call us back or write us back and tell us that this is not what you're asking. But I'll answer what I think you're asking. it seems that what's being asked is they need to graph this inequality. Y is greater than -1. Now, it said that there were spaces on the X and the Y. So I'm going to assume, and Nate, maybe you can tell me what you think, but I'm going to assume then that it is an XY coordinate grid and not just an X number line.
Yeah, that's what I'm thinking, more a coordinate plane with just, the range being 10 and -10. It's probably just what it looks like on the graph paper.
Okay, so these are the clues I'm getting. So it goes up to +10, and it goes down to -10. And then they said the same idea with the x-axis. So we'll just get this labeled real quick. Okay, so +10 and -10. -2, -4. Okay, so when you are graphing inequalities, when you graph, it's actually not just a line. It is an area that, because there is more than one thing that is greater than -1. So what we can do is actually start by graphing the line y equals -1, and then shade the region that applies to make that statement, that inequality statement, true. So what we'll do is we'll go on our y-axis, which is the vertical axis, and we're going to find where y is -1. What this means is it doesn't matter what x is, y is always going to be -1. And so if x were 1, y would be -1. If x were 4, y would be -1, and so on. So what that creates is actually a straight line called a constant function that goes horizontally across our graph. Now, I did that in dots for a reason. When we have an inequality where it's greater than, not greater than or equal to, so something like this, and it's not that, what we use to represent it is a dotted line, because when we're saying that y is greater than -1, we're not saying that it's equal to. So if we drew a solid line, that would be showing that it's also equal to -1. So it's just going to be a dotted line across, or a dashed line, just to show the boundary. And then we said that it's greater than -1. So on our y-axis, anything above the -1 is going to be greater than -1. So the region that we would be shading is everything above this dashed line. So I'll use lines like this to shade it, but you can color it in whatever you want. But so basically anything in this shaded region above this dashed line that I made is going to satisfy this inequality, y is greater than -1. So that's what a graph of this statement would look like. So hopefully that helps. And I hope I got the question right that you were asking.
All right, as we mentioned before, we're sponsored by Emily Griffith High School, so now we're going to take a couple minutes to hear a word from Emily Griffith High School and Emily Griffith Technical College.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
What's there to be afraid of?
I've never done this before.
I had no idea what it was going to be like.
I didn't even know how to turn on a computer.
Success requires facing your fears. I empower my students from day one.
We jumped right in, shooting.
I was excited from the start.
You have a camera in your hand more than a book.
And that's how you will learn. From start to finish, I don't waste your time.
It begins easy, then it gets harder and harder and harder.
I didn't think I could keep up, but then I got good.
I realized I can do this. Confidence is the goal. I love it when they see their potential.
I see myself doing professional work.
This is something I really enjoy.
I can see a story in everyone.
I'm not teaching video production. I'm creating storytellers.
Welcome to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
Hi, welcome back. Hopefully you enjoyed our commercials and got a little bit of information about Emily Griffith. If you are interested, get in contact with us. It's a really great school, and we've got a lot to offer.
There are a lot of opportunities there that just don't exist at other schools.
It's very, very true. It really is. Absolutely. So let's go back to Lily. We have we're at social media, but we're going to do something different right now. So Lily, tell us what's going on.
So right now we're going to do a Facebook discussion, and what we're going to be talking about is self-driving cars, which actually is accelerating pretty quickly, no pun intended. But this article offers an interesting perspective, and it basically kind of, I guess, explains that I guess self-driving cars aren't the problem, but I guess future drivers are. So, yeah.
So future drivers of
of
other cars around
self-driving
them?
cars. Maybe.
Yeah, that brings up a couple interesting points. Like if you have driven before, or if you haven't, a lot of driving is based on situational awareness. So if you ever wanted to try, whether you drive or not, just next time you're in a car, just take a second and think about everything going on around you that you kind of have to be aware of when you're driving. Like for me, I'm aware of teenagers driving around me because they may not be the most situationally aware.
True.
Yeah. Or if you see a police car, your immediate instinct is just to hit your brakes a little bit. So
They talk about defensive driving. I'm a very good defensive driver. So if I've avoided so many accidents based on, somebody not following or not using a turn signal, trying to go into my lane, and I have to merge out of the lane, or somebody turning left when they're not supposed to, something like that. So it is definitely very situational.
yeah, so driverless cars, they're all pretty much operating on just everything that they kind of compute around them. So they do lack that situational awareness a little bit, like in the sense of, I don't know, just
Anticipation
recognizing,
almost.
yeah, anticipation.
Like, that human aspect of you notice a teenager driving and you're thinking, she might not use her turn signal because, she seems inexperienced. A driverless car doesn't have that human aspect, that they can't anticipate, what might happen. I do the same kind of thing too with people turning left when I'm trying to go straight.
Right.
I'm like, oh, they kind of look like they're not paying attention. They're approaching this really fast, and I anticipate what they're going to do. Even though, let's say we're a driverless car, I think what the driverless car does is it calculates the distance you are from some things. And so it might not be able to anticipate that, for one. And then two, the humans being able to anticipate what your own car is going to do. So if your car is automated and you're, driving, and you're thinking, oh, I don't need to pay attention because my car is driving for me. Well, you might not know how the car really reacts whenever it gets within 10 feet of an object or something. And so a human being able to react to the robot aspect of the driver car also makes it difficult to predict and possibly to control.
Yeah. It's like using a calculator without knowing how to use it.
Right.
So-
It's great technology, but if you don't know how it responds and how to use it, then,
Yeah.
It might not be all that helpful. So.
Yeah, it's like they're more focusing on human behaviors rather than other things, I guess. It's technology is more focusing on us than technology itself, I guess.
It's
in a
interesting
way.
when technology, I guess, speeds up like that and advances like that. We have to, as humans, adjust to that, you know, and learn how to adjust to that. So
My grandma still doesn't know how to use the internet, so.
my mom doesn't either, but if you are interested in things like this, join our discussion on Facebook. You can comment, you can discuss, you can do all kinds of things. You can give us other ideas too as well. But I believe we have a caller.
Oh, we have another caller?
I think we have a caller. So let's get our caller. Let's answer the question. Are you there?
Yeah, I'm here.
Hi, how are you? Thanks for calling.
Doing pretty bad. This question has got
Oh
me.
no.
You know?
Well, how can we help you?
So it's x squared plus 7x plus 10 equals 0. I can't really seem to find the x. It's yeah.
Oh, were you possibly trying to get x by itself?
Yeah.
Okay, so I'm going to demonstrate probably the way that you attempted solving it, and then demonstrate another method that you could take. With these quadratic equations, they're called quadratics because the highest power is 2. A lot of times, we are trained in algebra to get the variable by itself. So undo, get variable by itself, just get everything undone. And so what possibly could have happened is you would have subtracted 10 to start with, and then you end up with this x squared plus 7x equals 0, and then get stuck there because, well, if we're trying to get x by itself, the issue is you've got 2 different x's, and they're not like terms, and you can't put them together and combine our like terms to isolate it. So another way, and there are actually 3 ways to solve quadratics, and I'll list them, and then we'll go with the easiest one. So one of them is the zero product property. The other is by completing the square, and these might not resonate with you if you don't know all of them, and then the last one is with the quadratic formula. So you've got some choices when you have a problem like this, but we're going to go with zero product property. That's probably the most simple in this scenario. So zero product property is basically using the idea that anything times 0 is 0. And that's a property that you've probably known for a long time. So basically, if we have something a times b is 0, so something in factored form, like I was talking about earlier, where it's multiplied together, if we have, what that means is that one of these factors has to be 0 in order to give our answer, or make our answer 0. So if we can take our quadratic equation and we can put it into factored form, where it's something times something equals 0, then we can figure out our pieces, because one of them has to be 0. So what we'll do is we're going to factor it. If you were watching our show earlier, I described one of the methods to factoring an expression. Another method to factoring an expression is by using the area model. And that uses the idea that length times width equals area. And if we can take our area and factor it, break it down to the factors, the things multiplying each other that equal it, then we've factored it. So this general form here is going to be the area. And then the outside, we're going to find the factors, or the things that multiply to equal it. So we broke it into pieces just because it's a little bit easier to find out the pieces rather than do the whole thing. And then, so x times x is going to give us x squared. And then we need to think of things that are going to multiply together to give us 10. And then when we find these little areas here, the top right and the bottom left, those add up to give us this middle term here, the 7x. So 2 and 5 are going to do it, because 2 times x is 2x. Oops, 2x. and then 5 times x is 5x, and when we add those two together, they'll give us 7x. If you tried 1 and 10, wouldn't work. That would give you 11x. So this is kind of an example of something that doesn't work. So basically, the factored form of this is x plus 2 times x plus 5 equals 0. And now it's in this form here, where it's something times something equals 0. So we use the idea that either one or both of these have to equal 0 in order for our equation to be true to help us solve. So we'll set each one equal to 0. We'll say x plus 2 is 0, x plus 5 is 0, and then we're going to get each x by itself. This one we'll get by itself by subtracting 2 from both sides, so we get x is negative 2. And then on the right side, we have x minus 5. And we get x is negative 5. And so these are our two solutions. So did that look familiar to some of the stuff that you're doing in class, possibly?
Yeah, a little bit. You were right the first time with how I went wrong, so this was starting to make more sense.
Okay. Yeah, you just, with those quadratics, you just really can't get x by itself when you have x squared and an x term in it. So you have to use one of those three methods. The other one I might suggest is quadratic formula. Is that something you're familiar with?
Yes, a little bit.
That's another one that would also work with this, but you just can't isolate x by undoing really very easily. You can, it's just not very easy. It's kind of difficult, so. So did that help?
Yeah, it's, I got it.
Okay, great. Okay, well, thank you for calling in. We appreciate your call, and I hope your day gets a little bit better now that you have some guidance on your homework.
All right, I just want to give you a quick reminder. We still have that trivia question. So if you think you know the answer, the question was, which word is the most mispronounced word in English? If you think you know the answer, give us a call at 720-424-1666.
And I'm going to add that there is a prize to that. So there is a prize. Oh, well, I guess time's up now for our trivia question.
That was quick.
5, 4, 3, 2, 1. Better call in quick. All right, we'll give you a little bit more time. So we'll give you a little bit more time. We'll answer one more question. We'll answer one more question, and then once we get the answer to one more question, then we're going to give you the answer to trivia question. So you better hurry up and call in. There is a prize, though, by the way. I'm going to take it if nobody else does. All right, let's go to Lily. Let's get another question answered.
Okay, so the top question we have right here is, if the height of a triangle is 5 inches less than the length of its base, and if the area of the triangle is 52 square inches, then what is the base and height?
All right, I think I can take that. It's another geometry question. And in addition, it's another system of equations question. So maybe that's just where everybody is in the curriculum right now.
That's like the theme this week. Yeah, must be.
I also think with just these systems questions, because of the two variables, it throws people off a little bit.
Yeah.
And it's just really about kind of breaking this problem down into two problems instead of one.
Right.
So I'm going to go ahead and write down kind of some of this information. We know the height of a triangle is 5 inches less than the length of its base. So first of all, we're looking for the base, for what the base equals, and we're looking for what the height equals. So, well, we know kind of what the height equals. All we really know is that it's 5 inches less than the length of its base. So the height is 5 inches less than the base. So height equals base minus 5. That's the first piece. And so we don't actually know the height, but we know kind of the height in terms of the base. So again, we're looking for is we're also saying that the area of a triangle is 1/2 the base times the height. And this problem said that the area in this case is actually 52. So again, what we have is 52 equals 1/2 the base times the height. So we have, again, two equations here. We have height equals base minus 5, and we have 52, the area, is half the base times the height. So again, the issue with systems is that we always have two equations and we have two variables, but we really need to narrow this down to one variable in order to solve. So right here, again, we have the height written in terms of base. So all we do is we're going to work with this equation right here, and we're going to plug in the value of height. So 52 equals 1/2 the base, which we don't know yet, times h, which is now base minus 5. So going into solving this, all I'm going to do right now is simplify everything. 52 equals half of b times b, or b squared, minus, and this is a little tricky, 1/2 times the base times -5. So we want to multiply the -5 times 1/2, which is going to give us minus 5/2 the base. This problem looks like it's going to get a little messy. So it looks like we're kind of going back into solving another quadratic equation. So what we'll have is, here we want to kind of isolate the variable b on its own. So we'll move this 52 over.
Oh.
Yeah, it's getting a little messy here. So we have 0 equals...
Could we multiply
1/2
the whole equation by 2?
That's a good idea, actually. I wasn't even thinking about that.
It'll make your numbers nicer.
Yeah, so a lot of you might hate fractions. I love them, which is why I didn't think of that. But
I don't.
That's fair. I totally understand.
I taught them. Well,
Yeah.
I taught them for 5 years. Ugh.
So what we could do is actually, to get rid of this fraction and simplify things a little bit, is we can multiply, this entire thing by 2. And really what we're doing when we do that is we're saying, well, I can multiply the left side of my equation by 2 as long as I do the same thing to the other side. Now, if we factor that out, well, 2 times 0 is just going to be 0. And then going to the other side, we're going to distribute that 2 to everything inside of the right side of the equation. So, like Becca mentioned, great advice, makes things a lot easier. 2 times 1/2 is just going to be 1. So we have b squared. -5/2 times 2, we get -5b, right? These 2's are just canceling out. And we have minus 104. So it looks like, again, we have a similar problem where we can either use a zero product property, or we could use quadratic, or possibly completing the square. So what I like to do first is think about whether I can factor this. It's a little quicker generally.
Yeah.
What do you think? It's kind of complicated.
Yeah, I was looking at it real fast. I think this is going to be one with no solution, actually.
No solution.
Because your discriminant in the quadratic gives you... No, actually, I lied.
Should
It
be
has
okay.
a solution. We're good.
Well,
I
so
lied.
this is one of those problems.
I'll solve it for you real fast over here.
You got it?
Got it. I'll do
Okay.
it real fast.
Oh, you already
Keep
got it up
talking
with
and I'll
quadratic.
solve it real fast. I'll come
So,
up with an answer for you.
Look, this is one of those problems where, yeah, it might be possible to factor, but when you see these really big numbers, one of the things I like about the quadratic formula is it always works, no matter kind of how ugly the numbers are, how big they are. Factoring is generally quicker, zero product property, but quadratic formula is always going to work. So if you don't want to spend a lot of time trying to kind of guess and check these factors, then quadratic is going to work. And I think Becca has that on her screen,
I got it.
all set up.
So I plugged in our, so this is, we can talk about this for a while, but we're running out of time. So this is the quadratic equation that I mentioned earlier. I plugged in all of the values, and then I simplified and got 5 plus 21 over 2 and 5 minus 21 over 2. When you do 5 minus 21 over 2, it gives you a negative number, and we're talking about geometry here, so distance can't be negative, so we're going to throw out the negative number. So we're going to throw out the negative answer, and the answer that we do end up getting that does work is 13.
So, and that's actually only half of our answer.
Yeah, that is half
Problem's
of our
not
answer.
done.
So let's go back to your screen, and we can kind of finish solving for this. So we found what B is, the base.
Yeah, so the base of this triangle is going to be 13. So again, this is kind of a big problem. We can come back again like we did before and use either one of these equations. Area is half of base times height. or height is base minus 5. I'm going to choose this one because, again, there's no need, no matter what your math teacher says, to make these problems more complicated than they need to be. So if I know the base is 13, I know the height is the base minus 5. I can easily solve this and say height equals 13 minus 5. So the height is actually 8. And that's solving our problem. A lot of steps there.
There we go. So that was actually, that's a very big problem.
Yeah, I didn't realize it when we started it. And then
nice,
the quadratics.
Nice teamwork there. So if you have more questions about quadratics, though, let us know about that. So we can definitely, because we did not explain that very fully. All right, so let's go to Lily, get answer to our trivia question. I'm dying to know.
Finally.
All right, so I'm going to restate the question, which was, which word is the most mispronounced word in English? And that's pronunciation. Pronunciation. Just to help you guys out there.
So it's not pronunciation?
I mean, that it might be. I don't know. You got me there.
You could be pronouncing
I could be wrong.
Incorrectly. Who knows?
Yes.
Oh my goodness.
Oh, it's pronunciation is how people Yeah, that is how you say it wrong is pronunciation.
Makes
so
sense.
pronunciation is
Interesting, because I've never actually heard anybody say it like that. But I guess, you know, the two words combined, I could see how you'd make that mistake.
Yeah, I mean, pronunciation is it's spelled differently than pronounce.
Right.
So that makes sense.
Yeah, but there are a lot of words that are pronounced incorrectly, or there's a lot of words that just are debatable, like Caribbean. I have a lot of these arguments. Caramel.
Which one do you say?
I don't know. I think it just depends on which side of the argument I start on, and I just really stick to that.
You know, the one that I mispronounce all the time is and I'm gonna get made fun of 2 for 2. I call it a gyro.
Oh, instead of a gyro?
Instead of a gyro.
Oh, yeah. Mm-hmm.
And it's not because I think it's pronounced gyro, it's just because it's a regional thing. In Pittsburgh, I'm from Pittsburgh, and in Pittsburgh, they all call it gyros.
So they might look at you funny for pronouncing it correctly.
They make so much fun of me here for calling it.
What about pecan or pecan?
Yeah, oh yeah, that's a good one.
Or a mix between the two, pecan.
Oh, yeah.
I've
never said it that way.
That's
how you say it?
I probably pronounce a lot of things incorrectly, so sorry, Homework Hotline. Math is my game. But that's like a language too. Math is.
It is.
It's like a language too. Like order of operations. If you do order of operations wrong, you're basically speaking the language wrong because you're just jumbling everything up. Like
yeah, I always think about too, since we talked so much about quadratic equations, one of the questions I always get is like, why do we have to put the squared term first? And it's kind of like the same reason you put words in order when you have a sentence, because if you put it in the correct order and everybody puts it in the same order, it's a lot easier to understand that way.
Right, that uniformness.
Right.
So I guess whenever you're pronouncing pronunciation, if we can be uniform about it and all agree on it, then it's easier to understand. Because imagine if you're an English language learner.
Yeah.
And you're like, is it pecan or pecan and you don't know the difference, and it just makes it more difficult if there's not that uniform. What are some other ones that?
You know, the other interesting, since you mentioned English language learners, the other hard thing about English is that one word can have 2 different meanings just based on how you
like homophones, like polish and Polish, and tear and tear. I don't know. All right, well, thanks for joining us on Homework Hotline this week. We'll be back next week on Tuesday, Wednesday from 4:30 to 5:30. Thanks for your questions.
Thank you. Looking forward to next week.